there, math analyzers. Welcome to your Chapter 10, Lesson 7 notes all about the tangent function. So we have been exploring sinusoidal functions for a while now, but let's jump all the way back to Chapter 9 and our unit circle and remind ourselves about this fun trig function called tangent, right? So of course we know that if we're dealing with our angle in question right here, the side opposite right here, the y side, is actually my sine function because in my unit circle, 1 is my radius, and that is my hypotenuse side, and sine is opposite over hypotenuse. Cosine is the adjacent side over the hypotenuse side. So cosine ends up being equal to my x value because adjacent side is right here over 1, which is my hypotenuse side. So we do have these two values, which means that each coordinate along the unit circle is actually your cosine, your sine, right? Your cosine, then your sine. But tangent is different. For each point, your tangent is the opposite, which is, of course, your y side, divided by your adjacent, your x side, which means to figure out, and this matches up right here, to figure out your tangent, you take your sine divided by your cosine, right? When we were looking at the unit circle, what that meant was in quadrant 3, where both sine and cosine are negative, it ends up being only tangent that's positive here. And that's because you have a negative divided by a negative. We know that that makes a positive. And that's really the only thing we've talked about with tangent so far. We really kept it limited. But the thing that happens because of that relationship, because the relationship is the y divided by the x, is there are spots where some real funky stuff happens in the tangent function. So let's look at the tangent trig function in each of these spots. So what I'll do real quick is just pull up my graphing calculator. And we'll make sure we're in degree mode. So my mode needs to be on degrees, and I arrow down to where radians is, and then arrow right to degrees and press enter. So now it's highlighted, and then I press second in mode to go back to my home screen. So let's plug in the tangent of 0, which is 0, okay? Well, that makes sense because that would be at 0, y is 0, and x is 1, right? So 0 divided by 1 is still 0, okay? Now let's do tangent of 30. Oh, right. This is going to be an irrational number because this would end up being, if at 30, remember your sine is going to be 1/2. That's going to be your top number. And your cosine is going to be radical 3 over 2. And so let me put it this way. Sorry. In parentheses, 1/2. And then divided by radical 3, X out of that, over 2. So if I'm dividing those two things, my y value divided by my x value, that's what I get, which ends up being the same as radical 3. We actually looked at that a while back. Oh, sorry. Radical 3 over 3. My bad. Which ends up being radical 3 over 3. Right? So we actually looked at that a while back, but now at least we know, and we'll write this down. We know what this equivalency is, and then we'll just put this in decimal form, rounded to the nearest 10,000th. That's 4 decimal places. Now let's try 45. Well, what's any number divided by itself? Any number divided by itself is a 1, right? So the tangent of 45, which is radical 2 over 2, divided by itself, radical 2 over 2, because both x and y are the same at this point, that's 1. Because any number divided by itself is a 1. All right, keep going. Tangent of 60, well, this is going to be radical 3 over 2 divided by 1/2. So let's see what we get there. That's the radical 3, right? because radical 3 over 2 divided by 1/2, let's just enter that so you can see it in person. Radical 3 over 2, and then divided by 1/2 ends up giving me radical 3. And we know that from above, but I'll just type it in one more time. There it is. So we know that this tangent of 60 is radical 3, which is 1.7321. We're rounding to the nearest 10,000th, right? Wait a minute. Now we have a value over 1. We've never had that with sine or cosine. It's interesting. And that's because so far, whenever we've been around the unit circle, the radius is 1. So the maximum value I can have for something has been 1. But now with tangent, I can be greater than 1 as a value because I'm not talking about points around the unit circle anymore. I'm talking about dividing sine by cosine around the unit circle. And where that ends me up is tangent of 90, so the top of my unit circle, is a domain error. Do you know why? It's undefined. It would be 1 over 0. Your y value at 90 degrees is 1. Your x value at 90 degrees is 0, right? You can't divide by 0. Tangent is undefined at 90 degrees. So that becomes a really interesting function graph as a result. Okay. Now, what I want to do before I move too far along, right, is these are all the radian equivalents for our degree measures here. So these are exactly the same on both sides. Okay. So we'll still know that the tangent of 0 radians is 0. The tangent of pi over 6 radians is 0.5774. The tangent of pi over 4 radians is 1, because that's 45 degrees. The tangent of pi over 3 radians is 1.7321. And the tangent of pi over 2 radians, which is 90 degrees, that is undefined. Okay, and the reason that I want these equivalencies written down is because when I go to graph them on a trig coordinate plane, obviously those are typically in radians. So that's why I want to know what those measures are. Okay, those equivalent measures. So, of course, here are some of our answers for sine and cosine. And again, we have to consider that tangent is figured out by taking the y and dividing it by the x, which is taking the sine and dividing it by the cosine. So when we go here, we get that undefined value, right? Well, okay, let's consider the unit circle. This is not the only spot at 90 degrees. That's not the only spot where your x value is 0. Where else is your x value 0? So you're dividing by 0. At 270, you have an x value of 0 and a y value of -1. You get another undefined place for tangent. So actually, at 270, or 3 pi over 2 radians, you get another undefined spot, which means that the tangent function has lots of asymptotes. So this is what the tangent function looks like. This is not the same as unraveling the unit circle the way that sine and cosine were. This is taking all the points around the unit circle and dividing the y by the x. Okay? Essentially, the slopes, okay, the rates of change around the unit circle, the y divided by the x. Okay, that's what you're looking at. And you'll notice that there are asymptotes at 90 degrees and 270 degrees. But what does the tangent function do until then? Same thing every time, right? 0, 0, then you've got 45 degrees right here. which is the same as pi over 4 radians, that's where you're going to hit 1 right there. Okay. And then continues up and as close to the asymptote as possible. Then you're going to have, so there's your 45, here's your 90. So here is your 135, right? Notice that that's going to be down here at -1. And that makes sense because of where we are in the unit circle at 135, right? Think about 135, it's right here. So you're in the negatives for tangent, right? That makes sense. Tangent is only positive in quadrant 3. Quadrants 1 and quadrant 3, excuse me. So here we are down here in the negatives. Then we get to pi and we're back at 0. And that makes sense because at 180, our y value is 0. Our x value is 1. And then over here, now this guy, we're on the other side. Well, this is where the third quadrant is. 225 degrees, we're back to having a positive 1 as our matching value. And then at 270, it's an asymptote. And then again, we get to the next, just past 270, we're in the negatives. That's 315. So just past 270 for your 45, that you get to 315. You're in the negatives for this one. And then, of course, you're back at 0, back on the point where we start our unit circle, which is 1, 0. That's where the tangent function goes. These are the key points in the tangent function. This is truly just something I would memorize. You can plug these into the graphing calculator, of course, as we did, to test them to make sure that this is working. But I would just memorize where these points are. So comparing all three, the sine, cosine, and tangent, comparing all three, there's always an asymptote starting at 90, every 180 degrees. Tangent has an asymptote. All right. So starting at 90. So if you're going back this way, it would be at -90 and +90, then 270. Then after you get to 360, right, you'll go another 90 degrees. So at 450, you'd have an asymptote. So there's always going to be that asymptote. Okay. So down here, where you're kind of putting this all together, all right, sine, of course, is 0 and cosine is 1 when you're looking at 0 degrees, 0 radians. So, of course, tangent is going to be 0. So that's this divided by this. Remember that. Sine divided by cosine. That's what tangent is. Okay? So now at 45, it's radical 2 over 2, radical 2 over 2. And at 45 degrees, both are positive. Any number divided by itself is a 1. So that's where we get this 1 from. But now when we're up at 90 degrees, sine is 1 because we're at the top of the unit circle, and cosine is 0. That's where we're undefined. So that's why we get the asymptote. I'm just kind of putting it all together there. Then at your 135, so sine is going to be negative, and cosine is going to be positive. Because we're x values. I said that backwards. We're positive y values there. Negative x values, excuse me. So we're going to have that, a positive divided by a negative, giving me a -1. Again, this is quadrant 2. That's the reason for that. We get down to this point of 180. Well, now we have 0 for sine and -1 for cosine. So since that's the case, we're right on the x-axis again. Since that's the case, we end up back at 0 here for 180. And then here with the 225, you actually have both sine and cosine negative. And as a result, a negative divided by a negative is a +1. Then you get to this 270, where on our unit circle, you have a -1, but a 0 because we're on the y-axis. So your cosine is 0. And so since we're dividing by 0, that is undefined. There is your other asymptote for the 0 to 2 pi range. And then after that, we end up with the negative sine radical 2 over 2, but the positive radical 2 over 2 for cosine, because we're back in the fourth quadrant where x is positive again. And that ends up giving me a negative 1 here. And then, of course, we're back up to our original point, 0, 1, which gives me a 0 for 360. That's where we get our tables from. So let's graph that. I'm just going to take those tangent values that I just put on here. That's all I'm going to copy over. So 0, 1, undefined, -1, 0, 1, undefined, -1, 0. Back up. Okay, you ready? Remember that 90 degrees is an asymptote, so let's get that vertical asymptote right in there. And that 270 is an asymptote, so let's get that vertical asymptote right in there. Okay? 0, 1, 0, 45 is halfway, so we'll say 1 is up here, and -1 is down here. So this is just like that. Then here, your 135, then 180 is 0. Then you've got your 225. So 135 right here is down at -1. 225 right here is up at +1. So it's, and there you go. Arrows at each end, heading toward the asymptote, but not touching it. And then, of course, halfway here is your 315. That comes down here to -1 and then up to 0 right here. And so whoop, close to your asymptote, but not quite. That's what the tangent function looks like. We're going to go backwards with it. So go into the negatives this direction. So that would mean here, you're down here to -1, and your asymptote is at -90, and then at -270. So that direction for your two asymptotes. So then whoop, that way. Now we'll just whoop this on both, right? In and back out for tangent, just like that. And then, of course, here, and this one is positive this way. Yep, we're up here, heading toward the asymptote. Interesting, right? Tangent is interesting. So if we're sketching this, and this is pi, just keep that there so you can see it still. So if we're sketching this, this is pi, this is 2 pi, this is 3 pi, this is 4 pi, because we're supposed to be sketching this to 4 pi. Your asymptotes are at 90, 270, and then up past it, 450, and then what's that guy? Uh, 630, right? So I'll write them up here. 90 degrees, 270 degrees, 450 degrees, and 630 degrees. I didn't have that memorized, sorry. Now let's get them on there. So here, oh, there you go. Here is this way, and then out this way. Here is this way, then out this way. Here is this way, then out this way. And here is this way. Stop right there. That's a tangent function right there. Asymptotes at 90, 270, 450, 450, and 630. Asymptotes starting at 90 every 180 degrees after that. All the pi over 2's. Think of it that way. All the pi over 2's have the asymptotes for tangent. Okay? And again, all of this circles back, see what I did there? To your unit circle. It all comes back to the way the unit circle is built. It always does. Because we've got the 1 as the radius, that gives us the sine as our y values, the cosine as our x values, and then that itself builds us the tangent function, because tangent is opposite over adjacent. It's the two sides instead of the hypotenuse side of your triangles. And so that becomes the sine over cosine. That's it. We just have to be able to sketch tangent, know that the 45s are the ones and the negative ones, and know that all the pi over 2s are where your asymptotes are. So as long as you can sketch tangent, you'll be in great shape. Alrighty, friends. See you soon. We are almost done with chapter 10. Getting there sooner rather than later. Have fun with our homework, and I'll see ya. Bye.